Hello, my dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. So let's start to welcome to our channel. Today is lecture number 3 of nucleophilic substitution reaction. In previous lecture, we studied about the generality of nucleophilic substitution reaction, general reaction of nucleophilic substitution reaction. We already studied that different nucleophiles when they react with alkyl halide, they replace the halogen group of the halide group of alkyl halide with the nucleophile and generate different functional groups. So in today lecture we will be studying that we will study different factors that affect Sn2 reaction, like the factor like there are some factors that affect the nucleophile in nucleophilic substitution reaction, some factors that affect substrate in the nucleophilic substitution reaction, like there is some nucleophile that act as a strong nucleophile, or some nucleophile that act as a weak nucleophile. So different factors affect the strength of nucleophilicity, while the strength of substrate, the reactivity of the strength of substrate toward nucleophile, different factors affect that. So let's start today's topic. Are you ready? Okay. Sorry. Sorry. Both the nucleophiles, both the nucleophile and substrate are important, as well as type of solvent used, These both are also important in Sn2 reaction. So let's start the nature of nucleophile affects the rate of reaction, affects the rate of Sn2 reaction. It affects the rate of Sn2 reaction. Strong nucleophile is much more effective than a weak on attacking an electrophilic carbon. Item. For example, both methanol CH3OH and methoxide ion, these both are act as a nucleophile. Both have free lone pair. Both act as a nucleophile, but this nucleophile methoxide ion, this nucleophile is strong nucleophile, while this nucleophile is not in a strong like methoxide ion. So what is the factor behind that? What is the factor that affect the strength of nucleophilicity? So let's start the factors. The first factor, negative species will be act as a stronger nucleophile. Negative species will be act as a stronger nucleophile as compared to the same species of neutral, same neutral species, that is neutral, like here is CH3, that is the one factor. Negative species will be always act as a stronger nucleophile than the same neutral species, like CH3O negative methoxide ion. It contain 3 lone pair, while CH3OH it is neutral species, while CH3O is a negative species. So this species will be stronger nucleophile than this one, like NH2 when here is negative charge will be act as a stronger nucleophile than NH3, which is neutral nucleophile. That will be act as a stronger nucleophile. The NH2, then all the negative species will be act as a stronger nucleophile as compared to the same species when they are neutral. So in general, we can say that in C methoxide ion, this is methoxide ion, this is methoxide nucleophile, methoxide ion, while this is methyl alcohol. So methyl alcohol is weaker nucleophile, about 1 million times slower than in a reaction in Sn2 reaction. Methoxide ion will 1 million times faster than methanol ion, methyl alcohol. And because methoxide ion has a negative charge, but as I told you that negative species will be always act as a stronger nucleophile as compared to the same species that was neutral. Actually, in methoxide ion here is three lone pair available to sharing electron pair are more, while in case of methyl alcohol it has less number of free lone pair that can be available, that is available for donating far to are taking on any electrophilic carbon. So let I show you the reaction of both these, the methoxide ion as well as methyl alcohol. In case of methoxide ion, where there is three lone pair, so when they take on electrophilic carbon CH3 H, when there is methyl iodide as a substrate, when they react this species, they first of all they form transition. So the transition will be like that, CHO, that is CH, H, and that is I. So here the bond between methoxide ion and carbon will be partially formed, while the bond between carbon and iodide, bond between carbon and leaving group will be partially break. So that's why it will be denoted from dotted lines. But here in case of iodine, the bond of iodine and carbon, that is partial. Iodine is most electronegative, it is electronegative element, so that's why its electronegativity is greater than carbon, so that's why it will have partial negative charge while the carbon will have positive charge. That's why the carbon will be act as an electrophile for attacking, for that the nucleophilic attack, that is will be ready for nucleophilic attack. So the nucleophile, which is methoxide, that will be attacked on this carbon and formed transition state. In transition state, this iodine will have partial negative charge because electrons are donating toward the iodine, while in case of methoxide ion this has already negative charge, so the partially half electron will be shared to the carbon, means half bond will be formed, so that's why partial negative charge will be remain in this case. But in case of this transition state is the state of methoxide ion, while in case of the when there is methyl alcohol, or you can say that simply methanol. In case of methanol, where is two lone pair electron, when they react on any electrophilic carbon, when they attack on any electrophilic carbon, here is same situation. The iodine has partial negative charge while carbon has partial positive charge. This carbon will be, this lone pair will be attack on this carbon, that is electrophilic carbon, so the transition state will be like that, that will be CH3OH dot CH that is bonded with I. Here is same situation, iodine will have as a partial negative charge because iodine is electronegative element, and the bonded electron will be shift towards iodine. But here in case of, here is oxygen is neutral species, and in this situation they partially donate the one lone pair to the carbon. It means that two already bonded oxygen with one methyl group and one the hydrogen group, when they bond the third bond, when they just as they bond third bond in case of methyl alcohol in this transition state, so that's why the the lone pair will be partially donated to this carbon, that's why they will be get partial positive charge. So this is why this transition state will be unstable, this transition will be unstable while this transition will be stable, because here is oxygen bonded with three different groups, while in this case here is oxygen bonded with two, and oxygen has partial negative charge, while in this case oxygen has partial positive charge. While oxygen having partial positive charge is more reactive, it has less stable, very less stable, very unstable, while in case of oxygen having more the negative charge, and oxygen atom will have more the stability. Actually, all the cation having positive charge, all the cations that have positive charge, they want that they get more positivity. When they get more positivity, they will be more stable. When the anion that is negative charge, all the negative charge wants, all the electronegative elements want that they get negative charge, that's why they will be more stable. So here is same situation, CH3O is electronegative elements, they get here is partial negative charge, while in case of methyl alcohol, when they attack on methyl iodide, in case of Sn2 reaction, here will be positive charge come on oxygen atom, that's why they will be act as a unstable, they will be show more reactivity. In case of methyl alcohol or methanol will be show less reactivity towards methyl iodide in Sn2 reaction, while in case of methoxide ion will show more reactivity towards methyl iodide in case of Sn2 reaction. That's why we can say that all the negative charges will be act as a stronger nucleophile as compared to the same species that are neutral. Here is one other conclusion arise from this topic. You can take screenshot or you can rewind the video. I am just cleaning the board because of lack of space. From this discussion, we can generalize the case of methanol and methoxide and to say that a base is always stronger. Base will be always stronger. A base is, that is generalized. Base is always a stronger nucleophile than its conjugate acid. Base is always a stronger nucleophile than its conjugate acid. That is very important. You should need to remember this sentence everywhere. A base is always a stronger nucleophile than its conjugate acid. What this mean? This is when CH3OH, that is methanol, when methanol lost one hydrogen, when this act as a acid mean according to Bronsted theory, those species that can donate proton will be act as an acid, while those species that can accept proton will be act as a base. So this species, when they lost proton, it will give us conjugate base, O negative plus H positive. Or you can say that this is the base, these two are the pair, conjugate acid base pair. This base, methanol is the conjugate acid of methoxide ion, while methoxide ion is the conjugate base of methanol. So that's why you can say that a base is always, and as I already told you that see all the negative species that, like CH3 or that is methoxide ion, that is stronger nucleophile than methanol. So that's why we can generalize that base is always a stronger nucleophile than its conjugate acid, because base is, it is the base but it is its conjugate acid. So we can say that base will be always a stronger nucleophile than its conjugate acid. I hope you will be clear this point. If you have any confusion, you can ask me in comment section. And we might be tempted to say that methoxide is much better nucleophile because it is much more basic. This would be methoxide, it is stronger nucleophile because it is much more basic as compared to the methanol. This would be a mistake because basicity and nucleophilicity are different properties. Basicity and nucleophilicity both are different, but let's differentiate basicity and nucleophilicity. Let's differentiate. If you can differentiate basicity, what is the difference between good base and good nucleophile, then you can comment me, then you can define me, you can differentiate me in comment section. Just define, just type the definition of base and nucleophile, and basic difference between base and nucleophile. Just type and post in comment section. So differentiate between base and nucleophile. What is base and what is nucleophile? What is base and what is nucleophile? Basicity is defined as the equilibrium constant, equilibrium constant for abstracting a proton, equilibrium constant for abstracting a proton, While what is nucleophilicity? Nucleophilicity is defined as the rate of attack on attack on electrophilic carbon atom. Nucleophilicity defined as the rate of attack on electrophilic carbon atom, while base defined as the equilibrium constant for abstracting a proton. Mean the relation of base will be act as this. This is base plus that is basicity. This is basicity. When there is a proton present with any acid, so base will be act as a proton, and base will be here. The nucleophile will be act as the negative species, or the species that donating electron, the donating lone pair will be act as a base, and they abstract a proton. They will remove proton from this species, and the product will become this. The product will be like this. It will become BH, and the A will become negative. Acid will become negative. So this will be here. This is called basicity constant. This is called basicity. This is called base. This group, according to Lewis concept, all those species that can donate a proton, that can donate a lone pair, will be act as a base. So here this is act as a base. While in case of nucleophile, here one species that act as a nucleophile, when there is an electrophilic center means there is any center that have the deficiency of electrons. So when there is deficiency of electrons, mean there is some positivity, some positive charge, because when they are bonded with any electronegative elements, the atom that are bonded with any electronegative elements, so that's why the electronegative element will be withdrawing electrons. So the atom will be get partial positive charge, and the electronegative element will be get partial negative charge. So this partial positive charge will be act as the electrophile, and the species that are donating the electrons will be attack on this carbon, and this deficient electrons, deficient atoms, deficient atoms of electrons. So the group will be the leaving group are the species, the group that have the atoms that are the most electronegative, that will be left by the group. So this will act as a nucleophile. This group, this according to this concept, this species that are donating lone pair, that will be act as a nucleophile, so that they are attacking on electrophilic carbon. While in this case, the species that are donating lone pair, they will be abstract a proton from the acid. That's why they will be act as a base. So these are two different things. Base and nucleophile are two different things. One similarity between base and nucleophile: in both cases bond formation will be occur. Bond formation between the attacking group, like that is either base or nucleophile, and the atoms are the protons that was attacked by the base nucleophile, the bond between them will be generated. So bond formation, new bond formation will be occur in both cases. New bond formation will be occur in both cases. These are the similarity between these two things, between base and nucleophile. New bond formation will occur in both cases. While in case of base, the bond will be formed. In case of base, bond formation will be occur. Bond will be formed between between bond will be formed between base and base and proton. While in case of nucleophile, a bond will be new bond will be formed between new bond will be formed between nucleophile and electrophile. New bond will be formed between electrophile and nucleophile. Electrophile are those species. Electrophile are that species that have the deficient electron, that are poor in electron, that have deficiency of electrons. So these are electron. So these are some differences between nucleophile and base, while one is the common thing in both having in both cases new bond formation will be occur. I hope these 2 points will be cleared. You can rewind the video, or you can take screenshot from this. I'm just cleaning the board because they got space. And one point is remaining. I will explain you. Here one thing is remaining. Mostly nucleophiles, but not all. Mostly nucleophiles are also strong base. While vice versa, because mostly but not all strong base are is a good nucleophile. So a good nucleophile will be act as a strong base mostly in most cases. And the other thing is, not all the nucleophiles will be there is not all the nucleophile, not all the strong base will be act as a good nucleophile, while there is some cases where the species is a good base, is a very good base, very strong base. There may be some situation that not be a strong base. A strong base must not be must not be must may not be a strong nucleophile, and vice versa. Vice versa means a strong nucleophile will be made, must maybe not a strong base. Let's I explain this points. If you please take screenshot from this. I'm cleaning the board because of lack of space. Yeah, here is three species. Here is two species. One is tertiary butoxide ion, while one is simply ethoxide ion. Tertiary butoxide is this CH3 CH3O negative. This is tertiary butoxide, while ethoxide is CH3 CH2O negative. Both have oxygen atom. In both cases, oxygen have 3 lone pair, means the number of free lone pair in both cases are same. So in which one will be strong nucleophile and which one will be weak nucleophile? If you have answer, please comment me. Pause the video, please. Okay. In both cases, here is 3 electron donating group present. Here is only two. Here is only 1 electron donating group present toward the alpha carbon. Yeah, here is 1 electron donating group present. Here is one methyl group. Here is 3 methyl groups attached. In both cases, here is in the tertiary butoxide, this will be act as a good base, that will be good base, but not be, but act will be weak nucleophile. Act will be act as a weak nucleophile and act is well, while at the same time it will be a good base. While ethoxide ion, it will be act as a good nucleophile. It will be act as a good nucleophile, while at the same time it will also be act as a weak base. What is the reason behind this? If someone can question you that which one is strong base and which one is weak base, this will be weak base and this will be strong base, while this will be good nucleophile, strong nucleophile, this will be weak nucleophile, this will be poor nucleophile. Yeah, this will be strong nucleophile. So let's explain. If you have reason, you can comment me, please pause the video and comment me. As I told you that base will be those species that are taking on proton, that abstracting on proton from any species, that abstracting on proton from any compound, while nucleophile will be those species that are taking on electrophilic center, on positive center, on electron deficient electron center. So when there is groups in this case all the methyl groups that will be act as a donating that will be donate the electron, that will increase the electron density on oxygen atom because of more the number of alkyl groups, more the number of electron donating groups. That's why electron density on the oxygen atom will be increases, it will be increasing. But in case of ethoxide ion, the electron density on oxygen atom here is only 1 electron donating group, so that's why here is not enough electron density as like in tertiary butoxide, and that's why tertiary butoxide ion will be act as a, when they attack on any proton, they will be act as a good base, they will be act as a good base, while at the same time they will be, so as compared to the tertiary butoxide ion will be good base, while the ethoxide ion will be weak base when we compare both of them with each other. While at the same time this will be act as a weak nucleophile, because nucleophile is those species that can attack on electrophilic center. Let's suppose that the carbon is electrophilic center, this is the electrophilic center. When tertiary butoxide attack on this carbon, here is 3 bulky groups, 3 heavy groups attached, 3 bulky groups attached. These bulky groups will show steric hindrance to the nucleophile. This bulky group shows steric hindrance to the electrophile, to the attacking center that was attacked, to the center that is attacked. They will show the steric hindrance, that's why they cannot be easily approached to the center, while in case of, so they will be act as a poor nucleophile, while in case of ethoxide ion they will show very less steric hindrance. It show very less steric hindrance because here is a here is only 1 bulky group, while in case of tertiary butoxide here is 3 bulky groups. So 3 bulky group will show more steric hindrance, while 1 bulky group show less steric hindrance. That's why ethoxide ion will be act as a good nucleophile as compared to the tertiary butoxide ion. Or you can say that ethoxide ion is act as a weak base while a good nucleophile, while tertiary butoxide ion is a good base while weak nucleophile. So this means that it is not necessary for any strong nucleophile that strong nucleophile must be as a good base. Because here we see that there is some cases like tertiary butoxide and ethoxide where these both things are different. One will be act as a strong base, but at the same time it will be act as a weak nucleophile. And similarly, when they act as a weak base, when they act as a strong nucleophile, they will be act as a weak base. So these two things are not similar, but mostly in most cases, strong nucleophile will act as a strong base, but not in all cases. I hope this point will be cleared. If you have any confusion between the, the difference between base and nucleophile, you can ask me in comment section, please. So now let's I show you some trends, the nucleophilicity trend in periodic table, where in a long period and a long group, what will be the nucleophilicity trend? Are you ready? Okay. So here is three trends of nucleophilicity. Trends of nucleophilicity. Nucleophilicity. Here is three trends of nucleophilicity present. Number first trend is species with a negative charge a stronger nucleophile than a similar neutral species. Species as species with a negative charge, as I already explained you, as a negative charge is a stronger nucleophile, than a similar species, neutral species, yeah, it will be act as a stronger nucleophile in a similar neutral species. Like in case of OH, when this is negative charge, it will be act as a strong nucleophile than H2O. It will be act as a strong nucleophile than H2O. In case of NH2, when they are negative charge, they will be strong nucleophile than NH3. NH2 as negative charge, it will be act as a stronger nucleophile than NH3 because NH3 is neutral species. Similarly, SH negative is act as a stronger nucleophile than SH2, which is similar species that are neutral. So it means that all the negative species, all the anions, that all these species that are negative charge will be act as a stronger nucleophile than those similar neutral species. This is the first trend. The second trend is another trend is nucleophilicity decreases from left to right in periodic table. Nucleophilicity decreases from left to right in periodic table. Why it decreases from left to right in periodic table? The nucleophilicity decreases because electronegativity increases. A reason is because electronegativity increases from left to right in periodic table. As the electronegativity of the electronegative elements have more tightly, we know that the electronegative elements have more tightly held non-bonding electrons, like in case of that is fluorine, which has 4 lone pair fluoride ion, while in case of OH that has while in case of OH that has in case of OH, where the central atom is oxygen, which has low electronegativity than fluorine. OH is negative species. So in this case, fluorine has more electronegative element, and we know that the more the electronegativity means that they are more tightly bonded. Their valence electrons, are their bonded electrons, are their free electrons, lone pair of electrons. But in case of oxygen, which is low electronegativity element, that is not enough tightly bonded with the nucleus of the oxygen as in fluorine atom, because fluorine is most electronegative element. That's why the lone pair of fluorine will be not easily available for donating, or will not be easily available for taking an electrophilic center, but in case of oxygen it will be available. It will be act as a good nucleophile. So that's why nucleophilicity a long period in periodic table, it will be in decreases from left to right, or you can say that it will be increases from right to left. The nucleophilicity will be increases from right to left in periodic table. It means that OH will be act as a good nucleophile than fluoride ion. Similarly, NH3 will be act as a good nucleophile than H2O. Is it clear? Because NH and nitrogen has not enough high electronegativity like the electronegativity of oxygen. So that's why electronegativity, the nucleophilicity will be decreases from left to right in periodic table. I hope this point will be cleared. You can also take screenshot. I'm just cleaning the board because lack of space. Sorry. Or you can rewind the video. The third rate is nucleophilicity increases from down the group, increases from down the group, increasing from top to bottom, increases down the group or from top to bottom. Why it increases? The nucleophilicity increases because the size of the atom or size of the ion or size of the molecule increases from top to bottom or from or down the group. When they are increases, as the size increases, as the size increases, as the size increases, polarizability will be also increases, polarizability will be also increases, polarizability will be also increases. When polarizability also increases, high more polarizability means that the atom will be good, the atom will be like that, that is the atom of fluorine, that is the atom of fluorine, while that is the atom of iodine, that is the atom of iodine. So polarizability means the size of the iodine is greater than fluorine. So this why it will be act as a, let's suppose this is the carbon atom, this is the carbon atom. In both cases, in both cases the situation will be like that. The fluorine will be like that, they will be polarized like that, that is the carbon bond, carbon orbital. While in case of iodine ion, where this is the carbon, this is the carbon, this is the carbon orbital. While in case of iodide ion, that will be polarized like that. It means that more the more the size, larger the size, larger will be polarizability, larger will be polarizability, or you can say that larger the size, larger will be polarizing, larger the size and larger will be polarizability. Yeah, so that's why they will be act as a good base, that way that that will be act as a good nucleophile. For example, that is fluoride ion, that is chloride, that is bromide, that is iodide. When these ions are down the group, the nucleophilicity will be increases. Iodine will be more, iodine will be act as a good nucleophile, while fluoride ion will be act as a weak nucleophile as compared to iodine or chlorine bromine. So that's why down the group, the reaction rate will be increases, the rate of reaction of nucleophilic show more reactivity towards electrophile and Sn2 reaction in Sn2 process. Mm, I hope today lecture will be clear. These are one factor that affecting nucleophilicity. And in next lecture we will be studying the steric effect on nucleophilicity, that which one will be act as a good nucleophile and which one will be act as a weaker nucleophile. Not in next lecture, but I am explaining just now. The second factor on nucleophilicity, esteric effect on nucleophilicity, esteric effect on nucleophile. Let's suppose there is here is two cases. Here is two cases in that is as I already explained you. Here is tertiary butoxide ion. Here is tertiary butoxide ion and ethoxide ion. In both cases, oxygen has negative charge. Oxygen has three free lone pair of electrons that can be donated, that can be act as a nucleophile. So in both cases, the nucleophilicity will be more the number of bulky group, more the number of bulky group will be show more, it will be act as a, it will be show more repulsion, it will be show more resistance, it will be show more steric hindrance to the electrophile that, on which the nucleophile attacked. Yeah, when in this case it will be like that. In tertiary butoxide and CH3 O negative, O negative. In this case, when they are attacking on any carbon, any nucleophile, any electrophile, when they are attacking on this carbon, this resistance, this these two groups, these three groups will be show steric hindrance to the carbon. While in case of ethoxide ion, CH2O negative, O negative CH3, in this case of CHHX. In this case, here will be very less steric effect, because but it will be no steric effect because here is only one bulky group present. But in case of tertiary butoxide, here is three bulky groups, so it will be show more resistance. Here will be no resistance, here will be no repulsion, here will be no steric hindrance produced. That's why more larger the steric hindrance, smaller will be nucleophilicity. Larger the steric hindrance, larger will be resistance to the reaction. Larger the steric hindrance, smaller will be the reaction. The reaction rate will be smaller. The reaction rate will be very slow. While the smaller the steric hindrance, larger will be the reaction rate. Is that clear? It means that in case of when there is ethyl, alcohol, when there is ethyl alcohol, it will show act as a stronger nucleophile. While in case of propyl alcohol, while in case of isopropyl alcohol, it will be show less nucleophilicity. It will be show less nucleophilicity than the ethyl alcohol, while that will be show very less nucleophilicity as compared to the tertiary butoxide. And it means that more the number of bulkiness, less will be nucleophilicity. Less the number of bulkiness, less the number of steric effect, more will be nucleophilicity. These all are about nucleophilicity. And next lecture we will be studying that what is the solvent effect on nucleophilicity. So what is the solvent effect on nucleophilicity? In next lecture we will be studying that topic. I hope today's topic will be clear. If you have any confusion, if you have any question, you can ask me in comment section, please. Also, please subscribe my channel. It makes me feel happy that my students are supporting me. Please support me. If you have any question, confusion, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from the description box. Okay, very best of luck, my dear student. Very best of luck.